A dice is used in playing a board game is suspected of not giving the number 6 often enough. So during a particular game, it was rolled 12 times and only 1 6 appeared. Okay, so 6 only appeared once. Does this represent significant evidence at the 5% level of significance that the probability of a 6 on the dice is less than 1/6? So how do we start off a question like this? Well, the first thing we need to do is we need to say, okay, this can be represented using a binomial distribution. Why? A binomial distribution, remember, it involves interest in only 2 outcomes. So we're interested in either getting a 6 or not getting a 6. So we can say let x, so we need to first of all define what x is. X is the number of times we roll a 6, because we're interested in getting a 6. We're only interested in getting the 6. So x will be that. So then we can say, since we're only interested in 6, the other outcome is not getting a 6. So we only have 2 outcomes. So therefore, we can actually approximate it using a binomial distribution. So we're going to say x can be approximated by a binomial distribution, which has how many trials? We're rolling it 12 times. So 12 is our number of trials. And what is the probability of success? Well, probability of success, probability of getting a 6 is 1/6 is what is assumed to be the norm for a fair dice. So that's our binomial distribution. Now for this binomial distribution, since we are doing a significance test here, hypothesis test, we need to then indicate what our null hypothesis is. What is H0? Well, H0 is what is the current expectation. What is the current assumption? The current assumption is that the probability of getting a 6 is equal to 1/6. So we're going to write down P is equal to 1/6. What is the alternative hypothesis? It's what is being suggested by the question. The question is saying, well, it wants us to test whether the probability of getting a 6 on the dice is less than 1/6. So it's suggesting we want to test if it's less than 1/6. So probability is less than 1/6 is our alternative hypothesis in this case. So here we've set up our distribution, binomial distribution. We've identified what our null hypothesis is. We've written what our alternative hypothesis is. Okay, and so we're going to do a 5% test at the 5% level of significance. Okay, so keep that in mind. So if we're going to start off by drawing our number line. Yes, it's a binomial distribution, so we can go and say 0 all the way up to 12 successes, i.e. 0 to 12 times the 6 can appear. But in the question, it tells us what that test statistic was, that out of the 12 trials, 6 only appeared once. So it appeared once. Now we're looking at the lower end because we're interested in the probability of it being less than 1/6. We're going to be looking at 0 to 1. Why up to 1? Because the dice only appeared on 6 only once. If it appeared 3 times, we would be looking at 0 to 3, for instance. Okay, so it really depends on what we are looking at. All right. So in this case, we are looking at only 0 to 1 because that's what appears here. It only appears once. So what is this probability? We split up our calculation number line into 2 sections. This is the calculator side. The calculator will work this out. And we are interested in this side. So we're going to say probability of x less than or equal to 1. Go and use our calculator, x, n, p. This is a binomial distribution, so we can go and enter those values here. What is x? 1. What is n? Well, it goes up to 12 tries. And the probability of getting a 6 or success is 1/6 is what we have assumed it to be, and that's what we use for our calculation. Work out what this probability comes out to be. And it comes out as 0.3813 when you type those values in your calculator. Okay, so this is what is appearing in the test. Now we need to compare this to the 5% significance level. Well, what we'll do is we'll turn this into a percentage. So 0.3813 is exactly the same as 3 times it by 100. So 0.3813 times by 100 is actually 38%. 38.13%. Now you can see that this value here is greater than the 5% significance level. Now you have to be within, you have to be less than the significant level in order to reject the null hypothesis. So because it's not less than 5%, instead it's greater, we then say, therefore, insufficient evidence to reject H0. So there is no evidence that the probability of a 6 on the dice is less than 1/6. So no evidence that probability of getting a 6 is less than 1/6 is essentially what that's saying. So that's us doing a one-tail hypothesis test. Why is it a one-tail test? Because we were only investigating whether the probability was less than 1/6. It would be a two-tail if we said that the probability is not 1/6, meaning that it could be less than it or more than it. Okay, so here we looked at how we do a hypothesis testing using binomial distribution.